Hey friends, Austin Leibel here to talk to you more about PySpark in Microsoft Fabric as a part of our ongoing series to help individuals learn how to work with Spark and specifically Python in Spark within the Microsoft Fabric notebook experience. If you haven't watched the previous sessions, go through and check those out so you can see how I got some of these objects into my Spark workspace. But what I want to focus on in this module is going through and talking about some of the additional capabilities of Delta Lake when working with a Lakehouse architecture. So what I have for you down in the notes of this video are some downloadable files that you can go through and get to be able to follow along with me if you are interested. Once you have downloaded that, go ahead and extract the files and make sure you have access to the .ipynb notebook file inside of that. That stands for IPython notebook. We're going to have an experience to be able to get all of access to everything that I'm going to be developing throughout this video so you can follow along. Do you want to learn more about Microsoft Fabric and Azure? Visit prag.works/Austin40 and you will save 40% on an annual on-demand learning subscription where you will gain access to over 100 courses. Now, on to the video. So what I'm going to do to gain access or import that notebook into this Spark workspace here is to go through and change what persona I'm in. I'm going to go over to the data science persona down here in the persona switcher at the bottom left-hand side of my screen. So by clicking on the data science persona, you are going to find that there is an import notebook option. Now there's a couple other ways to get here, but this is probably one of the easiest ways to find this experience. By clicking the import notebook, it's going to essentially allow you to upload a file, which is going to be uploaded over here to my Spark workspace, what I'm currently working in. So once you've downloaded that file, go ahead and put that wherever you need for your own personal use. I have my Delta Lake operations IPynb file right here. Open that up and it's going to import it into your Spark workspace. And it's going to happen very, very quickly. It's a very lightweight file. It doesn't have any data in there, but it's going to have access to build some data and ultimately load a new table to the Lakehouse that we've been working with. So once that is loaded, go ahead and open that up and let's kick off our Spark cluster. Now, one thing you might want to do beforehand is also go through and get a Lakehouse mounted essentially inside of this Spark notebook. So you have an ability to go through and add a data source using your Lakehouse Explorer over here and ultimately choose that existing Lakehouse option and choose whichever one you've been working with previously, but I'm going to choose this LH PySpark Lakehouse that we created in some of the previous sessions. Again, go through and check those out if you have not watched those already. So with this Lakehouse now kind of affiliated with this Spark notebook, I'm going to go ahead and kick off this first cell here, which is going to create a variable. It's a string variable called in tables/employees, which is where I'm going to ultimately end up loading all of this data and modifying this as we go along. Okay, so we got some of the setup done there. What we're going to experience next is creating some data. Now we're just going to create some raw data here with some employees from Pragmatic Works and some people who maybe don't work at Pragmatic Works any longer or never worked here to begin with, but we're just going to have some sample data to work with. So to begin with, we're going to create a list with some different values inside of it. We're going to create some metadata with some column names here. And then ultimately, we're going to build a data frame. Now we talked about data frames are essentially our way to store data in memory within a Spark cluster. With that, we're then going to print the schema of the data frame. So make sure we have these different column names associated with that. And then ultimately also show the records that we're creating here. So if we go ahead and run this code cell, it's going to kick off all the jobs and ultimately create that infrastructure for us. And this is what we're going to use as essentially our Delta table once we load this into our PySpark Lakehouse. So I'm going to have this data frame here. I'm going to load that data now, which is what this next code cell is going to achieve. df.write in the format of Delta, very important. It's going to be saving that down to my Delta path. So that Delta path again was established up here. It's going to be invoked throughout the remainder of the notebook as a way to keep kind of calling back on that string variable, just so I don't have to type the same thing every single time. So this has now been written over to my Lakehouse tables. I'm going to go ahead and refresh that, and I should see that there is a new table here called employees. It has that metadata again, column names, data types, and I should be able to ultimately go through and work with that and modify modify that. So our goal now, once we have this employees table, is to say, okay, what can I do with this? How do operations on my Lakehouse Delta table affect what is actually stored in my OneLake? OneLake, again, is kind of our managed data lake inside of Microsoft Fabric. That's a software as a service tool, but essentially it's provided for us and managed by Microsoft, so that we have this capability to easily work with the data across our entire organization and share that data very easily with one another, based on the necessary requirements, of course. Now, if I were to actually go over and look at this Lakehouse, which we'll do in just a few moments here, I would see that we have this Delta table and that we can actually see the underlying files of that. But before I do that, I'm going to go through and quickly load a couple of different libraries and some functions from some libraries into my code cell, my Sparks notebook here. I'm going to go and pull from the Delta tables and import everything there, and also work with the PySpark SQL functions library and import a couple of things from there. All right, so I'm going to go ahead and run this code cell to create that basically connection to my Delta table so that I can go through and actually connect with the underlying files on that table, right? So we'll actually use that in just a little bit, this Delta table variable. So what I want to do kind of now is go through and show in the Lakehouse where I have these Delta files and kind of talk about what a Delta file consists of a little bit more in depth. So I'm going to go back over to my Spark workspace here and then click on my Lakehouse, LH PySpark Lakehouse here. I'm going to be able to kind of physically see the data from this employees table. I'll be able to see like a preview of what that data exists as. But clicking on this ellipses over here, I can actually go kind of underneath the hood, if you will, and see the files that are manifested on this OneLake. Now, if you recall from previous modules, a Delta file is essentially a Parquet file where the data is kind of stored and the metadata stored a little bit. And then it also has this other folder in here called the Delta log. This Delta log provides the transactions, kind of like the ACID properties to kind of log what's happening with every single version of my Delta table. So I have this Parquet file here. It ends in like CAC2-C0000. That's going to be referenced inside of this Delta log file here, version 0. You're going to actually see that exact same file. So this is kind of keeping track of what's happening as we're going through and creating the table, creating the data on the table, and ultimately modifying and updating this over time. So back over in this Delta log, you see this is version essentially 0, the initial version. Every single time I update, I create, I delete, I do any sort of operation to this table, it's going to keep record of that in this location. So we'll kind of come back and forth between that just to verify and validate that that is occurring for us inside of our Lakehouse. So back over inside of my Delta Lake operations notebook here, I'm going to go and actually connect with that underlying data now that's inside of my employees table here. So I want to go and bring that in, right? Previously, we kind of created that data just from like raw data entry, but we're now going to go through and connect to the underlying data that's actually stored inside of my Lakehouse. And then we'll actually be able to view that data. So it's the same stuff. Nothing's changed yet. We're going to start to modify this here in a few moments. And how we're going to do that is we're going to go through and call upon that Delta table variable we created previously and make an operation to that. We're going to essentially delete records from that have a column of salary, so the salary column here, where the records are less than $5,000. So if anyone has a salary less than $5,000, we're going to delete them from our table. So we're going to go ahead and run this. This is going to make that transaction. This is a transaction that's going to be logged in our Delta log back over on our Lakehouse. And it's going to then give us only the new data that's present whenever we read from this again. So in order to verify that the data was deleted, we can go ahead and run this cell beneath that. It's going to look at the current status of our data frame and then bring that data back for us. And there we go. We've deleted 2 records from our table. So now if I go back over to my Lakehouse, what I'm going to see is if I kind of do a refresh of this here, I have a new Parquet file that's been stored underneath the hood for this employees table. And I also have a new Delta log file as well. We had version 0 before, we have version 1 now. If I were to also just look at this file in general, you're going to essentially see, once we do a little refresh on this, only the records that are going to be coming from this. And we should only see those records coming from that. The previous versions of that aren't going to be there until we actually load that data for ourselves. So ultimately, when we come back over here inside of our notebook, we can actually track and see the history with PySpark as well. We're going to be able to look at that delta table history and be able to show the last 5 records. Now, we don't have 5 records right now. We kind of just have 2 records of this. This is a little bit hard to read for me personally. Maybe you can read this a little bit better than I can. So another way to easily kind of go through and have this done as well is to choose the display option, so the display, and then say I want to display my delta table here, and it kind of comes in a little bit more easy to read form for us. We'll have to do a dot show as well, so we can actually see what we're looking at here. So the next thing we want to do is go through and update the data. We want to go through and do like an update. So I'm going to go and have some sort of new condition where if your name is Mitchell Pearson, like we have someone at Pragmatic Works named Mitchell Pearson, he's very popular with DAX. We're going to change his department that he's in to math, and we're going to change his salary to $5,005. So we give him a nice $5 raise there. Pretty cool. So now we go through, we look at again the current version of that data. We're going to be able to see that we now have the 5 records that are there. We can go through back and see again that that transaction was made on that table. So this is transaction 2 now. We can actually see here, this was an update. It has that predicate we used to update that. The previous one had that delete. It has that predicate that we used to delete that. So all of these things are being stored for us. Now, one of the really cool features of Delta Lake is the ability to go back in time and look at those previous versions of the data and what it looked like at that initial state. The version as of 0, the version as of 1. Now, you can do this with Python, with going back and looking from the table with this optional kind of feature here, version as of 0 or version as of 1. So this kind of brings us back to that initial state of what the data looked like historically. So we're reading from that version 1 where there were all 7 of our people. And then we also were able to go back and look at version 1 where there was just the 5 people who were made for us. Now, what I'm going to do here really quickly is run a couple of these code cells pretty quickly, just kind of get us going and kind of towards the end of this where I really want to focus in on a couple of other delta table operations that are important. So I'm going to run a couple of these. I'm going to bring some data in, some new data that's going to have a new record here, Laura Smith, and essentially do a merge. So this is going to do some merge statement to kind of have some sort of matched, not match, kind of using SQL-like syntax to be able to do this. So essentially we're going to be able to bring new records in for ourselves. And then we also want to be able to bring in and load that data from the data frame and then look at the delta table history of that as well. So again, we have this third action, this third version on our delta table that shows the merge, the predicate of that, how all of it was handled. And then we're going to run a couple of these really quickly. These are more like iterative of just the same thing. We're just going to delete one record one by one because I really want to get to a point in this delta table transaction log that's going to allow us to see what we call a checkpoint file. So every 10 transactions, we're going to have a JSON file as well as a Parquet checkpoint file that's going to be created for us to ultimately have some way to easily read through all of these files, right? Because you can imagine, let's say you're streaming some data into a Lakehouse and it's happening like at a very rapid rate where you're inserting records like every couple of minutes. The transactions on here are going to be just astronomical in number. So how do we go through and handle that so that it's optimal to read from all these delta tables? Ultimately, what's created beneath the hood are these checkpoint files. And we can go back over to our Lakehouse here and actually see those underneath the hood for ourselves. So going to the employees table here and looking at the files, we'll be able to see all of the Parquet files. Again, this is kind of all the state of how this delta table has changed over time. But in the delta log here, I need to run one more transaction, it looks like. We're going to be able to see a 10th transaction here that's going to give us some new data. So this will be the 10th transaction here where we're going to do a merge with some new people. Hey, there's yours truly right here. I've been promoted apparently to the CEO with a $1 salary. Very generous of me. And then we'll go ahead and look at the current state of this table as it stands now. So this is like where the table is going to stay for the remainder of our video session. No more updates or modifications are going to be made. But now come back over here one more time to our Lakehouse. If I go through here and look at that, this is that checkpoint file I was looking at, that Parquet checkpoint file that's also created alongside of a delta log. Now, this is important because ultimately this is going to allow us to read more optimally and the Power BI engine to read more optimally from this as well if it were to try and access this via direct lake mode, which is going to give you the best performance when you go and connect as a storage mode inside of Power BI desktop or inside of like a Power BI report. So you can get like lightning fast refreshes as well as real-time data as well. Now, coming back over to my Delta Lake operations, a couple of extra features that you can go through and work with when it comes to Delta is what happens over time, again, as you're receiving potentially thousands of records a day, thousands of transactions a day for all these new data sources coming into this Lakehouse table. How do we go through and handle all of the old data, right? What happens is we create more and more files, and some of those files kind of hit a retention period that we don't really need to keep that on hand any longer. Well, this brings us to a concept known as the vacuum operation. You can think like a vacuum cleaner. So with that, you can go through and run a vacuum on your Delta table to delete any records that are past a retention period. Now, you can set the retention period. By default, you have about 7 days for the files that are on the log as well as the actual like Parquet files that make up the table itself. There might be a little bit of a statement on there that's changing. It changes. I think the default for the log might actually be about 30 days. It says here, and the file retention is about 7 days. So there, the log's 30, the files are 7. There we find it right there. Put some documentation in here if you want to read through that, get a little bit. This is coming directly from like Databricks documentation where they kind of have some great stuff around Parquet there. But ultimately you can go through and change the log retention period for ourselves should we wish to. So for example, let's say I want to set some sort of log duration for 168 hours, which is in fact a full week. So we want to have a week set as this right here. We can run that to modify our log retention duration or potentially as well our file retention duration. And then with that, we would be able to, at some point, once we hit that weekly, however often you want to vacuum out this table, run that vacuum operation here. When I do that, it's going to go through, it's going to essentially look at all the files, look at their date, it's this timestamp for every single file, for every single log there, and say, is this within the retention period or not? And also, is this being referenced by the current state of the Delta table or not? If it's not, and it's past that retention period, it's going to be essentially be deleted from that table there. So if I come back over again into my Lakehouse, I'm going to be able to actually physically see that there was a transaction made that goes through and shows that happened. So even this 11 and 12 here right now, these are the vacuum operations. Those happened after I went through and ran that last part of my table there. But this is even, again, considered a transaction, cleaning up that data. It needs to know how to keep that referential integrity, to keep the reliability and the ACID properties on that Delta table. Another thing we can do to help compact and to help optimize Delta tables is to run the optimize command. And essentially this allows us to go through and take very, very small files and place them into larger files, but fewer larger files, right? Many small files versus fewer large files. We're going to get better read capabilities when we work with the larger, fewer files. So we're going to want to optimize the Delta table by running the optimize command. This can be done delta table.optimize.execute compaction. We also have an ability to change how we optimize this. There are many different kind of order by, Z order by. But ultimately, if you're like, Austin, I don't know, again, exactly how to run some of this. I see your code, but I don't know how to change it for myself. Here's the awesome thing about all of this. Microsoft has pre-baked in some of this stuff for us so that management of these different Delta tables does not have to be that complex. You can actually run some of these different vacuum and optimize commands directly from the employee user interface here. So if you go to your Delta table employees and you click on that ellipses, go to the maintenance category here at the bottom. And what that's going to provide for us is ability to go and run those same commands I was talking about previously. Run the optimize command, run the vacuum command, set that threshold for retention, This is just through the graphical user interface now. You're able to actually go through and modify that. So that is really exciting, makes managing these so much easier. You can also apply the V order optimization to maximize reading speeds in Fabric as well, which is going to be optimal for if you're going to be using Power BI to read from this in some sort of semantic model for reports and take advantage of direct lake capability. So very, very exciting stuff there. Ultimately, hope you had a great session here with me this time in our third session for PySpark in Microsoft Fabric. We're going to stop the session here. I'm going to go ahead and stop my Spark cluster just to kind of end that running in the background so we're not using that compute when it's not necessary. Hopefully you've enjoyed though. Hopefully you're ready to keep tackling more around this whole Lakehouse architecture, and seeing how easy Microsoft has made it is absolutely phenomenal. I love that kind of capability to go and run the Delta and the optimized commands. So you don't really have to even know some of the code necessarily, but if you want to kind of get more under the hood, kind of manage these a little bit more yourself, you have that capability as well. Hopefully you've enjoyed. I'll see you in the next one.